Hello everyone and welcome to this course on clustering analysis for healthcare with Python. My name is Valentine and I'll be your instructor. In this course, we'll get started learning about the learning objectives. After that, we'll talk about what clustering analysis for healthcare with Python entail. We'll go through important core concepts as well as why we would want to learn about those concepts. After that, we'll get to implement those concepts using the Python programming language. And in this session, we'll get to give you code examples as well as challenges that you can practice in order to be able to acquire the skills that we will set towards acquiring. Then towards the very end of the session, we'll just talk about the next steps. Starting off, what are the learning outcomes of this session? By the end of today or this learning experience, we are expected to have achieved these learning outcomes. We should be able to recall key clustering analysis terminologies to communicate clustering results effectively to healthcare stakeholders. We should be able to understand how common clustering algorithms, these are complex mathematical functions that allow us to segment or group just the data that we have. So we should be able to understand how those clustering algorithms work in the process of segmentation of healthcare data. We should also be able to create clustering models to solve healthcare problems such as patient segmentation or healthcare resource optimization. Clustering models in this case would be those programs that we would create that would learn from generally data and be able to segment the data that we want to segment. And lastly, we should be able to assess clustering models to determine their effectiveness in uncovering hidden patterns and trends in healthcare data. Starting off, what is clustering analysis for healthcare with Python? So this is generally a process that involves using what are called clustering algorithms, which are complex mathematical functions, to group patients or medical data or just generally data pertaining healthcare. And we would group such data into meaningful clusters or groups based on similarities in their characteristics, symptoms, treatments, or outcomes, and it could be extensive. And the idea or the goal would be to aid in segmentation. More specifically, could be patient segmentation. If we are working with patient data, could be disease diagnosis. So assuming that you are segmenting diseases data, then you could be able to provide diagnosis as per those segmentations or those clusters. You could also, as a result, be able to recommend treatment planning or even healthcare resource allocation. So for example, if you have a data set that contains information about health facilities and you perform clustering analysis, the end goal would be to have groups of hospitals. It could be groups that already are well equipped. As a result of your analysis, you might end up identifying that a certain cluster contains just hospitals which are well off, and another cluster contains hospitals or healthcare institutions which lack something, or they could be adequate patient personnel to help with generally patient care, or it could be other things, other properties that you might be interested in. So clustering analysis for healthcare is that type of analysis that allows you generally to group a data set into just clusters and then be able to make some sort of decision afterwards. There are various clustering techniques. However, the most common techniques when it comes to performing clustering analysis are k-means clustering, which we'll get to cover, and also hierarchical clustering. We'll cover these two types because they're the most common types of clustering analysis. There's also DB-scan. There are also other types of clustering that we haven't mentioned here. However, The first two are the ones that we're going to cover in an in-depth way, and we'll leave it up to you to be able to explore the rest of the clustering techniques. A use case pertaining to clustering analysis might be that a healthcare data analyst working for maybe a healthcare institution or company might use k-means clustering, which is one of the clustering analysis techniques, to segment patients or group patients based on their medical history. And that would, as a result, they would be able to represent, to have clusters which represent just different health profiles. So you would have maybe in one cluster patients who experience certain patterns depending on the data set, while in another group the patients would experience a totally different patterns. And the result of this is that healthcare providers would be able to tailor treatment plans for more effectively as a result of that type of analysis. So that's just one, but there are a few other types of just use cases, or not types, but just a few other use cases that might also just give you a better idea of how clustering is useful in healthcare. And some of those include patient segmentation. We've already talked a bit about this, where you cluster patients based maybe on diseases, or cluster patients maybe with diabetes into groups, maybe based on maybe insulin sensitivity, age, and comorbidities. And the idea would be to tailor medication and dietary recommendations. It could be that in some other use case, you might perform disease diagnosis and subtyping. So you could cluster maybe breast cancer patients into just these clusters, which if you do further analyze, you would realize that they might have, they might be clusters which belong to molecular subtypes based on maybe gene expression profiles, and that would help healthcare providers guide, have some sort of guide on treatment decisions. On the other side of, you might also maybe perform clustering analysis on a data set that contains hospitals or just healthcare institutions. And as an example, you could maybe cluster those records into clusters that represent geographical areas, or anything else that could be relevant in such a situation. And you might end up with maybe clusters that have maybe certain healthcare facilities which are able to access healthcare support from relevant stakeholders easily, while others are not able to experience that level of support. And as a result, the relevant stakeholders might be able to allocate resources, maybe resources such as medical staff or equipment. Yeah, so those are just a few, aside from maybe others might include fraud detection in healthcare insurance claims, or drug discovery and development, where you're able to work with data that allows you to be able to group maybe medications into different clusters, and that might be helpful in maybe treating some diseases. I did not, I think I forgot to include the explanation for that last point. I did forget. But yeah, so I think these use cases should give you now just a better idea of why you would want to perform clustering analysis. It's useful, especially when you have a data set and you're not able to get obvious signs, or you're not able to uncover hidden patterns easily. And clustering analysis can be able to provide you with just such kinds of insights. So once you have clustered your records that you have in a data set, you can then investigate further to understand what exactly about this group is special from the other group, and make some informed decision afterwards. In terms of how we perform clustering, so we would normally start by having, of course, before even performing any of the mentioned steps, we would need to first understand the research problem, whether stakeholders are looking towards identifying a solution that involves clustering. And when you've determined that, you'd then source for data that would be relevant for your analysis, for clustering analysis. You would load and preview the data, clean it, and pre-process it. That would involve performing encoding. Like, for example, you'd need to ensure that you do not have textual data. You need to convert the textual data into numerical representations. Could be using just label encoding or other encoding techniques. After that, you would scale your data set to ensure that some variables do not have a significant effect when it comes to clustering, that variables or variables that you have in your data set have good that they are considered easily when it comes to performing clustering. So there's no big advantage just on one particular variable alone. So after that, once you've performed scaling and you've done that, then you would perform clustering using some of the mentioned techniques. There's k-means. You could also use hierarchical clustering. And then you perform evaluation. So you determine the optimal number of clusters, because when you are clustering initially, you may not be sure about, especially when you use something like k-means algorithm, you may not be sure about how many clusters would be found within a data set. When you're working with an algorithm like k-means clustering, you would tell the algorithm to segment the data set into the desired number of clusters. You could tell it divide or group this or cluster or segment this data set into 3 groups. Then it does that. But later you need to evaluate to determine whether that would be the optimal number of clusters or that you would be working with, or that based on that particular data set. So generally that would be it. And then once you have done that, once you have your groups, then you can be able to further study them by performing maybe descriptive analysis, trying to investigate the individual records and seeing actually what each of the, not the individual records but clusters, what each of those clusters entail. Just to quickly go over just the 2 types of clustering algorithms that we are going to be implementing. We'll just first of all go through the first one, which is k-means clustering. And this type of algorithm normally works by partitioning data into what are called just into k clusters. So you would give it a number, like I want to cluster, I want to partition this data into 4 clusters or 3, then it would do that. So you would use this type of algorithm to partition data into the number of clusters that you want. But again, how it works behind the scenes, it usually minimizes what are called the sum of squared distances between the points and their respective cluster centroids. Normally we use this type of clustering technique when we would want to have a simple method of just clustering, one that can be scaled if we have a lot of data. And it also is able to produce well separated clusters. So the clusters that you get, they're usually distinct. In terms of evaluation, which we are going to get to learn, we can evaluate this type of algorithm by when all the model that we've created based of this algorithm by measuring the compartment or compactness of clusters. So we normally use metrics such as the within cluster sum of squares, or we can use what is called the Sillhet score or the elbow method, which is usually based on the within cluster of sum of squares. And the idea here is usually to determine the optimal number of clusters so that we can be able to know that our results are valid and they have well separated clusters that we can be able to use for further analysis of just being able to make decisions of them. The other type of clustering technique is called hierarchical clustering, which allows us to be able to create a hierarchy of clusters either by performing what is called merging or splitting. So hierarchical clustering usually comes with two approaches. The first approach is that you can start with the individual records and then group the individual records with another record that appears to be similar. And once you have grouped, those two records, then you would compare the result of that with another group or with another record that appears closer to now the result of that first grouping that you did. And the idea, you tend to build a tree. So you start off with the individual records, then you group those individual records into which are similar into just now just groups. Then you compare those groups. Then at the end of it all, you'll end up with one cluster. That is what the approach of that's called merging or agglomerative clustering pertaining to hierarchical clustering entails. And that's what we are going to be doing. And it's usually the most popular technique that we would normally use. There's the other approach, which is it's termed as splitting or divisive. And this involves having multiple, it actually involves doing the opposite of agglomerative. With agglomerative, you have individual records, you group them, but with divisive, you usually have all the one cluster, and then you would now subdivide the clusters into different groups up until you end up with one record. We won't be implementing that. The most common approach that works when it comes to hierarchical clustering is usually agglomerative, and that's what we're going to be using. We normally use this type of technique when we would want, when initially we do not know the number of clusters within a data set. So assuming that for k-means, we would tell it, okay, give me 5, then 5 clusters, then it would give you the 5 clusters, then you would then determine the optimal number of clusters. But with hierarchical clustering, you do not start with any number, you just tell it to just perform clustering, and then it gives you the individual clusters that make sense based on the data that you have available. So hence, the reason why we would say that we would use this type of clustering, because it helps us be able to reveal hierarchical clusters in the data, or structures in the data. And it's also able to handle what are called non-linearly separable clusters. And it's also easier to interpret. I think the non-linearly separable clusters just refers to the idea that the approach that this type of algorithm takes is a bit more complex as opposed to other types of algorithms where points are not able to be easily separated. So some clusters which are really hard to separate, maybe you might do k-means clustering, and when you do k-means clustering and you want to separate the records into 2 clusters and you perform evaluation, you might still end up not able to have just clusters that are really far off from each other. And in such a situation, then you can resort to using hierarchical clustering, which would help you to be able to get distinct clusters. The type of evaluation method that we use for hierarchical clustering is actually, it involves examining what are called dendrograms, which are just more like trees. And these dendrograms, they would display what would be just the merging process of hierarchical clustering. And yeah, so that's what we're going to be using. A limitation of hierarchical clustering, even though you can be able to create clusters for data that's hard to cluster, it consumes a lot of resources, computing resources, because it involves a bit of some complexity. That process of hierarchical clustering is computationally expensive, let me just say that, as opposed to something like k-means, which is quite simple. So yeah, so that's generally it with regards to just a quick overview of the types of clustering. We haven't gone deeply into the mathematics of it. I would just leave it up to you to explore all of that. Our next bit will now be to implement the two types of clustering techniques, and we will get to use Python for that. At this particular point, just have a look at the description that we have. Have a look at the description, the YouTube description, and click on the link, the resources link, that should take you to a page that looks like this, and then you should be able to download the sample practice resource. If you're an Afterwork member, of course, you can just work with the, you can sign in, then click on that link, and you should be able to access a practice resource, not a sample one. So starting off, once you get to the sample practice resource, the first thing that you need to do, for my case, I will use a practice notebook, which is just similar to the practice resource, only that it has more challenges. So let me reconnect this. This is classification, sorry. Oh, this is classification. I'll need to update that. Let me just do that in a second to just get the clustering analysis resources. Sorry for that. All right, so I think I've got them. So you should be able to see a page that looks like this, clustering analysis for healthcare. And then you can be able to access the sample notebook that looks like this. All right, so getting started, the first thing that you need to do is to save a copy in Drive. So you can go to File, then save a copy in Drive. It should open a new copy of this notebook in a new tab, and then you can close it. You can close the original one. I'm going to use the practice notebook. It's just similar to the other one. So yeah, so starting off, once you have done that, let me just zoom in a bit. 25 should be a bit clear. The next thing that you need to do, connect the notebook to Google servers, and then we can get started. It should take maybe about 5 to 10 seconds, depending on your internet. Well, it doesn't really depend on the internet, but sometimes it does. But yeah, let's get started. Prerequisites, we are going to work with pandas for data manipulation. So let's run that. Then let's first of all go through k-means. So assuming already we have a research problem in our data set to work with. So we're going to load the data. So the first step, data importation. So this is the data set that we're going to load. And it looks like this. It contains a list of patients and some other information. By the way, the data that we're working with is just meant for learning purposes. It's not real patient data. Yeah, so once we have this, we can see that we would need to ensure that our data is numerical. So we need to find the replace the numerical representation of the values for gender column. The same case for cholesterol and insurance coverage. We also need to split blood pressure into systolic and diastolic BP blood pressure. Yeah, so we do that, those changes by those updates by simply performing encoding. Here we're just using a map function, replacing the male values with 0, female with 1, and we replace the original values with the new values. The same case, we do the same case with insurance coverage. We also do the same case with cholesterol. So and also we split the blood pressure column based off this character and we assign both new columns to have integer data type, and then we create those ones, and then we drop the blood pressure, the original one, and we also drop patient ID because we don't need it. We also drop the missing values. For now, we could handle them differently, but for now, because it's a learning process, our focus is only on clustering analysis, not so much on handling missing values. So yeah, so once we have done that, we can be able to see now our new data set. For gender, you can see that we now have numerical representations of the old values. The same case, we have these two new columns. Insurance and also cholesterol have also new values. All right, so once we are done, the next thing that we need to do is to select the data that you want to work with, which is just all the columns. Technically all the columns. I should have just said data equals X, but it's still okay. I'm still the same column. And then once we have done that, we can perform feature scaling just to ensure that the bigger values that we have here are treated the same as the smaller values. So feature scaling, and you can just see our features now. Then we perform clustering. So to perform clustering, we would need to import k-means class from the cluster module in the Scalan. We instantiate it, and then we set the number of clusters. We want 3 clusters. I mentioned with k-means you would need to set the number of clusters, but we can evaluate whether that's the optimal number later. We set random state to 42 to just ensure that we get the same outcome if we are to share this analysis with someone else. So for reproducibility purposes, and we set also any need to auto. This is important as well when working with k-means. Then we train our model. Not really training, but we fit our model to the data. So we give the model the data that we have scaled. It's going to learn from the data and be able to perform clustering. So it's going to cluster the records into 3 different buckets. And to be able to get those clusters, we would need to say k-means labels, and it would give us whether each record was assigned a 0, 1, or 2, because there are 3 clusters that we want. If there are 2 clusters, we will get 0 and 1, and we replace those values inside data clusters. We have those values, we set them inside data clusters, so each record will have its own cluster, so we can then preview the outcome of that. And we can see each record has been assigned a cluster at the far end. So the first record has been assigned cluster 1, the second one cluster 0, third one cluster 0, and etc. The fourth and sixth has been assigned cluster 2. All right, we can then decide to display the individual clusters. Maybe if we wanted to plot maybe date and weight, we can be able to do that. And then we can be able to assign the once we have plotted it, assuming that those are the points, we can be able to have them. But this is not necessary. Shouldn't have even included this. This is not necessary. The most important bit is now having to preview each cluster. So I've just deleted that. I'll delete that in other notebooks. But here, this is what we're doing. So here we are just selecting all clusters, all records that have 0 cluster. So we're selecting a sample, not all, a sample of 5 records from each cluster. So from the first cluster, the second, and the third one. And we can investigate each cluster further by even performing data exploration techniques, etc. So yeah, so these are the clusters that would be of interest. We can study them individually and determine what each cluster entails and perform some action. If assuming the first cluster entails, these patients, it could be that these patients have something that's common, then we can be able to address that. And it could also be with other records that maybe if you're working with hospitals data, a data set that has a list of hospitals, you might end up having a group of hospitals, and you would need to just understand a bit more what's so much different from this cluster than the other cluster. Then we can check the optimal number of clusters using the elbow method. So I mean from the initial bit of explaining how we were able to work with k-means. K-means would minimize, it would partition data into k clusters, minimizing the sum of squared distances. So we would calculate, we would actually perform k-means for a range of clusters from the first, if we were to cluster our data into one cluster, 2 up until 11, and then we would determine for each the sum of squared distances, and then we would plot the number of clusters as well as the error that we would get from each of the clusters. And this would help us to determine, actually to get to see the optimal number of clusters. We're just using matplotlib in this case, and we can be able to see that for 2 clusters, actually for how we're able to get the optimal number of clusters, we would need to identify within our graph, this graph, where an elbow happens. So it usually happens at this particular point, which is just a change of direction, the biggest drastic change of direction within our plot. So you can see here 2. So technically 2 would be the optimal number of clusters for this particular data set that we have. And we can still update that. We can go back again and change here from number of clusters to now 2 instead. So yeah, you can change that to 2 and you can be able to get the 2. But again, I won't do that. I'll just leave it up for you to do that later. Alternatively, we can perform what is called Silhouette analysis. And this also is another type of method that we can be able to use to evaluate k-means. And what it does, it usually would calculate the Silhouette scores for each clustering that we would, for each clustering, whether it's for 1, for 2, for 3, for clusters, for each clustering, we would determine what is called the Silhouette score and be able to plot it against the number of clusters, and how we would interpret, or how we would arrive at the fact that how we would arrive at the optimal number of clusters based on this particular visualization is that we would look at the highest point within our graph, which is 2, and extrapolate that on the x-axis, which is number of clusters 2. So if you had maybe 6 at the top, you'd actually go for 6, or 3 at the top, then go for 3. And just basically it's like, we've confirmed that based on the elbow method, 2 was the appropriate number of clusters. In our case over here, the same case. And that's it. At this particular point, I'm going to ask you to work on the challenge. There are 2 challenges. You can work on the first one. And then once you're done, you can pause the video. You can also verify it. If you have access to the solution notebook, you can always verify your solution. All right, moving on, hierarchical clustering. This is another type of clustering that still allows us to group data. So we're going to load this new data set that contains hospitals data. So we have hospitals, and we have just information about those hospitals. We can then perform just preparation. Okay, we just selected just the values of the data, excluding number of beds, excluding location and name, but you can perform other data pre-processing techniques that work best for you. Well, for the use case, I wouldn't highly advise you to just select the numerical values. You can always perform label encoding and also just leave out the columns that don't make sense. But here we're just selecting, we're using also a different method. I could have just done, selected the individual columns or other methods. Then we perform feature scaling. Then we perform hierarchical clustering. The approach that we're going to be using is agglomerative, and there's an agglomerative clustering algorithm or class provided by sklearn that we instantiate, and then we pass our data to that cluster, that algorithm, and then we create a new column called cluster, and we assign the new clusters that have been assigned by agglomerative clustering, and then we can be able to see that each record has been given a cluster. For now, you can note that here we do not assign a category, we do not assign a preferred value for the number of clusters. We want agglomerative clustering just clusters our data set into the optimal number of clusters, but we can again check for the optimal number of clusters using what are called dendrograms. This is just a hierarchical representation of the clustering process, and we can be able to see how each record was clustered. We would use these two functions from the SciPy library. So this is just the tree of how, it shows us how each record was grouped. As you can see, initially record 1 was grouped with record 7 and 16. Record 7 and 16 actually looked much more closer to each other. The same case with other records. But how we determine that we have the optimal number of clusters, we would look at the horizontal lines, and we look at the ones that are longer, which is this one that you can see, and as well as this one, which are 2. So our assumption would be, or not our assumption, our conclusion would be that 2 would be the optimal number of clusters. Normally, you would even draw a line, across the 2 long ones, and you would state that because that horizontal line cuts the 2 longest lines within your dendrogram, then it would mean that 2 would be the highest number of, or would be the optimal number of clusters. And basically that's it. So the next thing would be just to work on the challenge. There are 2 challenges for determining the optimal number of clusters. And again, here you could always just isolate the two clusters and perform further analysis to determine what could be the case. And you could still go even further, and once maybe you've determined that this is the first, this is the third cluster, should have been third. This is the first cluster, the second cluster, you can still further, perform more clustering within those clusters that you have to just study a bit more what's happening. All right, that's it. Work on the challenges. They should be helpful in just ensuring that you have some good hands-on practice when it comes to clustering. And once you're done, we can wrap up the session. All right, so in this course, we were working towards the following learning outcomes. So we were to recall, clustering analysis terminologies, were to understand how those algorithms work, how to create those models, and also how to assess them, which we have. And as a next step, our recommendation would be to look into maybe other problems that you could solve using clustering. There are also other public data sets. If you go to cargo.com, you might find about clustering, not necessarily with regards to healthcare. But again, we provided enough practice in our notebook, and also a sample solution for you to be able to verify using the solution notebook. So once you've done that, you could always think about even just projects that you could work towards applying what you have learned today. A next workshop that we would recommend after this particular workshop, because this is usually part of unsupervised learning of machine learning. So it's usually, machine learning has 2 buckets. There's supervised learning and unsupervised learning. Clustering is one of those unsupervised learning techniques or methods that you could perform pertaining to machine learning. You could look into something like dimensionality reduction or market basket analysis, which is in some contexts called associative learning. So there are various other types of unsupervised learning approaches that you might want to look at, just to be sure that you're well off in terms of just understanding potential solutions with regards to machine learning that you might end up developing in case you get just problems that would require you to come up with a data related solution. So that's our recommendation. If you have any questions, feel free to ask in the comments section. And if you did love this experience, you thought it was useful, just to give us a sign that we are doing something good, just click on that like button. It just tells us that we should keep on continuing what we're doing. And if you'd want to be informed when we post such future videos, be sure to subscribe. And all the best in your learning journey. See you in the next learning experience. Bye-bye.